This is a demo for our work, embedding web agents into any customized UI. Most web agents operate at the interface level, parsing screenshots or DOM trees and mimicking human actions without access to underlying application logic. Yes, in enterprise settings where both front-end and back-end are accessible, embedding agents directly into applications enable richer application-level functionality, like executing complex actions, modifying visualizations, or navigating nested pages. However, few frameworks support this approach, and the thin ones fall short for enterprise use. Real-world UIs are often legacy, deeply nested and built on diverse web stacks, demanding stack-agnostic, modular solutions with minimal front-end changes and clean back-end isolation. Current frameworks are tightly coupled to web stack, require heavy front-end integration, and scatter agent logic across layers. To this end, we introduce a framework for embedding web agents into customized UI. It offers a clear division of responsibilities, minimal integration overhead, and robust action inference. The use case of our demo is about PFAS analyzer. PFAS are synthetic chemicals commonly used in consumer products like cleaners or packaging. PFAS are toxic and known to persist in the environment or accumulate in the human body. However, product reports rarely indicate PFAS hazards explicitly. Our web UI, powered by our embodied web agent framework, automatically analyzes chemicals and flags potential PFAS. So we are at the home page of our PFAS analyzer, and we have a chat box at the top. We first ask the agent to add all the chemicals from the product for us. Since our framework supports parameterized actions with mixed granularity, the agent can call tap and add to this as a single action. Our multi-agent workflow implements React and jump sort style planning. So the orchestrator invokes the web interaction agent, which outputs multiple actions in response to a single user query, reflecting on the current area text observation until the task is completed. At the end, the chat agent always summarizes what actions were completed for the user. Since we have an analysis agent with access to MCP tools, we can now ask the agent directly whether each compound is a PFAS using chemistry knowledge. This also shows our memory mechanism. We don't need to repeat the compound names because the agent will retrieve them from its own memory. The agent analyzes each compound with detailed chemistry knowledge. We now ask a more complex user query with an if condition and a multi-step workflow. The UI reflects the analysis dynamically. Next, we want to view the results as a pie chart. It's worth noting that we don't have a UI component for users to do this directly, but since the agent has access to the application level logic, it can modify the visualization under the hood. Now we want to navigate to a chemical information page. The agent does this by changing the URL because we have exposed all available URLs paired with area labels. We ask a question about molecular weight. The orchestrator calls the analysis agent with MCP tools. The agent fills in the results in the molecular weight table. We then ask a more domain-specific question about the structural similarity between two chemicals. The agent fills in the correct value in the similarity matrix. It knows exactly where to fill because every UI component has a meaningful area label. Now we go to the PFAS summary page. On this page, the user can ask the agent to show molecular structures of different compounds. We ask the agent to only show the PFAS structures and mark them as complete. This is again a complex user query with an if condition and multiple steps. The agent successfully completes the task. It interacts with the application level logic, looks up the correct image by chemical name from the library, and displays it. For experiments, we develop a suite of unit tests with Phoenix tracing to measure performance and verify latency. For every test, we can trace the reasoning of the LLM agent and analyze which parts succeeded or failed. Thank you for your time.